Hi all, welcome to my YouTube channel, Know About Embedded System. In this video, I'll be discussing about the two important things related to our embedded communication, that is our serial communication and parallel communication. So what is the signal? What do you mean by serial communication? Serial communication means data transmission, data transmits bit by bit. This is the definition. Data transmits bit by bit is called as serial communication. Under this serial communication, we have three types of communication. One is simplex, one is half duplex, and one is full duplex. So you can see the diagram here. What do you mean by simplex? Simplex means only one-way communication. So you have to understand only one way. There is no two-way communication. So we have, let us assume this is your TX, or you can say this is a TX, this is also TX, and this is RX. This is RX, this is also RX, and this is also RX. So we have three different use cases. One by one we will see. In case of simplex communication, data transmission will happen only in one way, transmitter to receiver. That's why here you can see the arrow is indicated in only one direction. This type of communication is called as simplex communication. The second one is called as half duplex. What do you mean by half duplex? Two-way, but one at a time. Two-way communication, but one at a time. This type of communication is called as half duplex. There will be two-way communication, but only one. So one at a time. So any one way, anyone is able to communicate, either transmitter or receiver. So this type of communications are called as half duplex. Then we have full duplex communication. So in full duplex, two-way simultaneously, two-way at a time or simultaneously. So this type of communication is called as full duplex, two-way at a time or two-way simultaneously. So there are three serial communications are there. One is simplex, half duplex, and full duplex. In simplex, only one-way communication. Half duplex, two-way but one at a time. And in full duplex, we will have two-way simultaneously or two-way at a time. So these are all small classifications under serial communication. I hope this is also clear to all. If you have any doubts, you can just comment in the comment section. So now after this, we will move to the important thing of serial transmission, how that serial transmission will take place. As I already told you, serial transmission is nothing but bit by bit by bit transmission. The serial transmission is nothing but bit by bit transmission. You're going to transmit a group of bits, but one bit at a time. In order to you can see here, this point here you can see. So we have TX and we have RX here, and a group of bits are transmitting bit by bit. It's not transmitting complete bits at a time, but instead of that, single bit is transmitting it in a single clock. So that type of communication is called a serial transmission. In that serial transmission, the first point is the bit by bit transmission. The second point, this is my first point, you should know. The first point says like that, and second point, there will be a small mechanism. So there will be protocol mechanism. There will be a protocol mechanism, and in this protocol mechanism, there are some conditions are there. So we will be having a start condition, and there will be having after start the data bits, and then stop condition. So if you want to transmit any data, three important things. If you want to transmit data serially, we have to follow three different conditions. One is called start condition, second one is called as data bits, and third one is called a stop bit. These three are very important in transmitting data. So when you give a start condition, your receiver will understand, okay, data is coming inside and I have to receive. Similar to that, so these data bits will be transmitted serially, and after transmitting all bits, we have to send one stop condition. And this is the second important point. And third important point is we will use minimum hardware. We'll be using only very less hardware we will use. Either for TX one line, TX line, and RX line. We'll be using minimum hardware we will use. One TX line we will use and one RX line we will use. Max to max, two or one or two line we will use in order to transmit a data serially. So this is a brief explanation about the serial communication. Now let us see how systematically the serial communication is defined in the theory part. Yeah. Now you can see here the same thing, whatever I had told, the same thing is explained here. In serial transmission, data bits flow from one device to the other device, either in bidirection or in a unidirection. If the serial transmission is a simplex, then it will be unidirection, and if it is a half duplex, it will be a bidirection. Okay. And in this transmission, one bit will flow at one clock pulse. This is what I told. The bit by bit transmission will happen. You can see here the bit by bit transmission will happen for every one clock pulse. Okay. And then the serial transmission uses 8 bits of transmission having, yeah, this is very important. This is what just now I told. If you want to transmit data, there will be one protocol mechanism. There will be some predefined logic is defined that is called as a protocol mechanism. There will be 8 bits of data if you want to transmit, and there will be one start condition and there will be one stop condition. Then only it is possible to transmit data in a systematically in a serial transmission. Of course, the next point you can see here, the serial transmissions are slow compared to parallel, because in a serial transmission we are transmitting data bit by bit. It will take some little time, more time compared to parallel communication. Okay, and generally the serial communications are utilized for a longer distance communication, and circuit is very small and very simple. Okay, these are all the features of your serial communication, and example, most of all our protocols follows the serial communication. All protocols such as UART, SPI, I2C, and even CAN. These are all the different protocols which utilizes serial communication only. What is the full form of all this? That I'll explain in the upcoming videos later. Okay, so I hope this serial communication is also clear to all. Now let us move to the next topic called as parallel communication. In parallel communication, the group of bits will be transmitted. You can see here I'm considering 8 bits at a time. In the diagram you can see we have a sender and we have a receiver here, but a sender will transmit a group of bits at a time. So what do you mean by parallel communication? Group of bits will be transmitted at a time. Will be transmitted. Group of bits will be transmitted at a time. But in case of serial communication, bit by bit will be transmitted. In case of parallel communication, the group of bits will be transmitted immediately. Okay. So if you consider 8 bits, the sender will transmit 8 bits at a time to the receiver. So usually the parallel communications are faster compared to serial communication. But what is the drawback with the parallel communication is parallel communication requires more number of lines and more number of hardware is required. And parallel communications are not suitable for long distance communication. Only the short distance communication you can use. Okay, so this is the explanation of parallel communication. Now let us see how it is explained in the slide. You can see here the parallel communication, how it is defined. The parallel communication, the many bits in the sense, a group of bits are transmitted simultaneously from one computer to other computer, or nothing but one device to other device. Now the parallel communication is faster than serial communication. Why? Because in case of serial we are transmitting bit by bit. In parallel communication we are transmitting group of bits at a time. And then parallel communication used for short distance. This is what I told. The parallel communication is suitable only for short distance communication, but longer distance we do not prefer the parallel communication. We always go for serial communication. Parallel transmissions are faster compared to serial transmission. And what is a major drawback here is relatively complex. This is a major drawback of your parallel communication. More complex hardware is required and it is deployed only for short distance communication. So we will not go for any long distance communication. Okay. So in parallel communication, any type of hardwares we can connect. The best example I'll give you, LCD interfacing. The microcontroller to LCD interfacing. This is one of the microcontroller to LCD interfacing and microcontroller to LED interfacing. Okay, and microcontroller to 7-segment GPIO, 7-segment, and stepper motor. Almost all GPIO configurations we will be using parallel communication. Whenever we are using GPIO interfacing, definitely we will go for parallel communication. We don't go for serial communication. The parallel communication we are going to use almost all GPIO communication. It includes LCD interfacing, LED interfacing, 7-segment stepper motor, and so on. Okay, so in these examples we can see the parallel communication. Okay, so I hope this parallel communication is also clear to all. So with this I want to end my video. So please subscribe my channel and get notified, and also we will also get motivation to create the videos like this. Okay, so thank you so much for watching the video, and keep on watching our channel, Know About Embedded System. Thank you. We'll meet you in the next video.